Alright, so now that we've dealt with the law of sines, let's take a look at the law of cosines. Of course, we're going to derive it, just like we derive everything that we possibly can. Okay, so let's take a look at this angle theta, and we're going to place the ray in the second quadrant. And when I do that, with this triangle that I have, nice obtuse triangle here, we have side A, side B, side C, and then of course angle B, angle C, angle A. If we wanted to come up with the coordinates of point B, we would need to have an x and a y, right? So the x coordinate and the y coordinate. Well, what this does is it makes a nice, our little reference triangle here that we can talk about. This angle right here is the reference angle for theta. So if we figured out the cosine of theta using this reference triangle, it will be using this angle right here. It's the same as the cosine of actual theta there. So the cosine of theta is going to be x over a, and then the sine of theta is going to be y over a. And if I went and solved these for x and y, I get x equals a times the cosine of theta, and y equals a times the sine of theta. And so that means that the coordinates for point B up here are going to be a cosine theta and a sine theta. All right, so that's great. Next thing I want to do is I want to come up with the coordinates of point A. And so since A is on the x-axis right here, and it has a length right here, or a value of b, I know that the coordinates for A is going to be b, 0. All right, so what we're going to do is, in order to drive this thing, we are going to look at the distance of this segment right here on the triangle. And so we're calculating C. And so we're going to use the distance formula for B and A for those points. So plugging everything into the distance formula, we take the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And so now it's just going to be a nice algebra game here to simplify this. I'm going to square both sides and get rid of my square root. I'm going to square the a sine theta, and I'm going to multiply this whole thing out. Remember, you got to FOIL it, right? So we get a squared cosine squared minus 2ab cosine plus b squared, and then this is just a squared sine squared. At this point, I'm going to rearrange this a little bit. I'm going to take this term and that term and move them together. So they're up front, so they're right here. From these two terms, I'm going to factor out an a squared, because then look at what this becomes. This is 1, right? Okay, so let's do that. I'm also going to move this b squared in front of the negative 2ab cosine. And I get a squared plus b squared minus 2ab cosine c. And that right there, folks, is one of the equations for the law of cosines. Okay, good. So let's put this all together and see all three versions of the law of cosines. So here they are. Really, just look at the pattern. This side, whatever side is over here being squared, you got to take the cosine of that angle at the end. So these letters should match up. So A, B, B, C, C. And then you use the other two letters for the rest of this. So b squared c plus c squared minus 2bc. Here's a squared plus c squared minus 2ac. Here's a squared plus b squared minus 2ab. So you can see this pattern. It really just depends on what information is given to you and what you get to plug in. And the reason that we would use this is if you have two sides and an angle that are included, then you can use the law of cosines instead of the law of sines. Also, if you know all three sides and you don't know any of the angles, you could use this to solve for one of the angles, A, B, or C. So let's put this into play. Let's see how this works, huh? So for this problem, I'm given side A, side B, and angle C. So in order to solve this, I'm going to actually solve for side C, since that's the angle that's given to me, and plug everything in. C squared is going to equal 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of 40 degrees. And folks, let me tell you, the most common mistake on these problems is people writing sine here instead of cosine, so make sure that you are taking the cosine and not the sine. Okay, so let's simplify this a little bit here. Square these, multiply. I'm going to add 25 and 64. Now I'm going to evaluate. I get c squared equals 27.716445. Just keep that in your calculator, right? And then hit the square root button, and we get 5.264, which rounds to 5.3. So now we have all three sides. But more importantly, we have side C that correlates to angle C, because now we can use the law of sines to do the rest. And I think you would probably agree with me that the law of sines is a little easier to work with, a little less work than the law of cosines. Of course, if you want to use the law of cosines for the whole thing, you go right ahead. Nobody's going to stop you. But here's a little warning. If you're going to use the law of sines to solve for the next angle, you need to solve for the smallest angle that's left. So when you look at, here's angle, or side C, 5.3. We already know that relates to angle C, so that's already set in stone. A and B, these two sides are the sides left over. When you compare them, which angle is going to be smaller, angle A or angle B? And hopefully you're saying angle A because it's the smallest side. So we are going to use the law of sines to solve for angle A before we solve for angle B. So 5 over the sine of A is equal to, and notice that I'm using my decimal here, extended decimal. I'm not using the 5.3. You don't have to use the big one that's still in the calculator, but take this out at least 3 or 4 places so you get a more accurate answer. And so now we can calculate this out. I did some little algebra manipulation before I hit the calculator. And we get, once you work this out, you get 0.61055 equals the sine of A. Remember, this is where we have to do the sine inverse on our calculator. So you might have to hit that second function or shift key on the decimal to get angle A, and it comes out to be 37.629 degrees. We are going to convert this into degrees and minutes. So remember, strip off the 37, subtract it, right? Get the 0.629 whatever was in your calculator, and multiply that by 60, and you'll get your 38 minutes. Okay, so now that we have angle A is 37 degrees, 38 minutes, we need to figure out what angle B is. And we're not going to use the law of sines to figure it out. We are going to actually just add angle C and angle A together, and then subtract it from 180. A lot faster. And it'll give you the more correct answer, too. Okay, so if we add those together and subtract from 180, remember to convert 180 into 179 degrees, 60 minutes, because we have to subtract minutes, we get 102 degrees, 22 minutes. Did I say 102? I hope I did. Okay. Anyway, so our final answer for everything that we have, we need side C, angle A, and angle B. And those are the 3 missing pieces when they asked us to solve the triangle. All right, so here's a question for you. What would have happened if we solved for angle B first instead of angle A? It's actually kind of interesting. All right, well, let's do it. Let's work it out. If we had solved for angle B first, that would have been 8 over the sine of B is equal to this big decimal divided by the sine of 40. Work it out, do the math. Okay, do inverse, sine inverse. We get, oh, look at that. Angle B comes out to be 77 degrees, some odd minutes, 77.655. Definitely not the 102 degrees, 22 minutes. Isn't that curious how they both came out to be different angles? One was obtuse and the other was acute. So the reason is your calculator is programmed in a certain way. that when you take the sine inverse, it's always going to give you an acute angle. It will never give you an obtuse angle. So when that happens, how would you know if angle B is supposed to be acute or obtuse? You wouldn't, because your sine, your inverse sine, is always going to give you an acute angle. And what we saw is it really should be obtuse. So just to make sure, when we do these problems, if you're going to do the law of sines to figure out your missing angle, make sure that you're choosing to solve the smallest angle first, because the smallest one will definitely be acute if the second one is obtuse. Maybe the second one's also acute and then it didn't really matter, but if it does, you won't know about it unless you solve for the smaller angle first. Does this make sense? So just remember that rule. Solve for the smaller angle first when you use the law of sines. If you do the law of cosines, it will give you an obtuse angle. The calculator is programmed to do that. Isn't that weird? Well, we'll be taking a look at why that is later on in this unit. Okay, there we are. We're done.